install everything from there. We need the leaf, we need, and then we import Ember, yeah, and set my train test data from what I have got from S3 bucket. And if I have to, in here, I want to take a look at original data set, and I see that this is the uh, file, and which is classified as give the label as malware or not. And in here we wanted to get rid of the rows without labels, and we again see the shape of our data set, and we see that we have 2381 features. And I defined this for task one. We have to define the convolutional model for getting this embedding with using embedding. And the output is Y1 because it is classification, and the result is whether malware or benign. And this code in this code, I use the embedding. This layer takes integer input represented byte value and map them into lower dimension and dense vector representation. This help the model learn a meaningful relationship between these byte sequence. Then I use a dual convolution layer with gating, and to separate one convolution layer are applied. This layer extract local feature by sliding a filter window across the sequence and capture pattern within the window size. Here the window size is equal to a stripe. Stripe effective extract non-overlooping feature. Padding is set to 0, meaning that the output sequence length will be shortened than input window size. The gating, the output from both convolution layer are element-wise multiple with the sigmoid function of second layer output. This gating mechanism allow the model to focus on informative feature from the second layer, while potentially supervise a less relevant one from the first layer. And then we apply max pooling. This layer make the maximum value across the remaining feature channel after gating step. And why we do this? This help the most prominent feature within each feature map effectively and summarize information from the convolution layer. And then we pass it to a fully connected layer, and this two fully connected layer are used. The first transform the pool feature into higher dimension represented using and I use ReLU as an activation function to bring nonlinearity to model, and this FTK and allow the model to learn a more complex relationship between feature and the output layer. The final layer use a single neuron with a sigmoid activation that use to define the probability of being to whether malware or benign. And also I test on the example input and see that the tensor is this shape, which is the one is the output of a model that we define here because it is classification. And then I use the Minimax model, Minimax scaler for normalizing the train and test data. I use fit transfer, xtrain, this scaler. I fit and transform the xtrain to Minimax scalar, and also do the same for test. And take a look at the data and see what it would be like. And then I guess this is the trick of this model, and I hash them because these data is not image or something like this, and they don't need to be in 3D channel. I also print the type of string because I want to see the how to define my tensor, and with that I figure out. Then I go to the next step, which is then I make my train set that I normalized before I pass it to take a tensor. Why it is long? Because it is byte embedding features, and this is discrete value and should be int and long, not float. But the original X-train is float. But we didn't do much anything on Y-train, so it can be float. It should be float actually. And then I split my train set to train and validation. And then in here I create a Malcon model instance and move it to GPU if available for accelerate training. Here I do that. And loss and optimizer. I defined my binary cross entropy for calculating the loss, and using Adam optimizer, and start my learning rate from this point and save my checkpoint here. The epoch that I'm going to run is 15 epoch, and also I use train. I define two variables for calculating train loss and validate loss, because of here I want to plot them and see whether the trend is decreasing or not, and the model is learning anything or not. And here I set the training group. It iterates over a specific number of epoch, which is 15. For each epoch, it set the model to train mode. It iterates over batch of data from the training data loader. It moves the input and label to design GPU or CPU, as I mentioned before. It perform forward pass, calculate loss, backpropagate gradient, and update the weight, and do the optimization in here. Yeah, in here. And it's set a model to evaluate mode. It iterates over validation data without gradient calculation. It calculates the average validation loss and print epoch result for training and validation loss. And it's also, I put it in here. I define that it saves the checkpoint every 5 epoch. And here I plot it, and as it can be seen, the trend is declining both for train loss and validation loss, and this plot. Yeah, and for tests, again, as you remember, first I pass my X test to a scalar to make it minimax, to apply minimax scalar on my test as well. Again, my test is long, my Y test is float. Then I calculate the here I define the threshold. Yeah, and might be not. And here it's defined whether the model is classified malware or benign in by help of this code, and it can be seen the accuracy is for the test set is 73%, the precision is 69, and the recall is 84. Deployment, I use pip install torch, git clone to there, pip install imber, and for not getting, if you install the leaf latest version, which is 0.30, you may, for running this section, I frequently get the error of bad formatting Ember. So it's better to install this version. And then import. These are two samples that I get for check my model. And here I define my model. This is loaded, as I mentioned. And here I explain them all in the inference.py, and here, as it can be seen, it runs successfully. And when you pass this to file and define the label, it can make a prediction and predict it as a benign because the label is 0. And then in here, I try to this part. Yeah, I try to run this code, get the model, and now define the class PE file for prediction and the version, and let's say it is running. And now go to Bootstrap and go to connect it to S3 bucket and pass this model to my S3 bucket. And then here I run it, and as it can be seen, it is run successfully. And when you try to run this, it's completed. But here I get error and I couldn't fix it.